In our previous class, we looked at just roughly I explained the strategy to solve material balance problem. Okay, we have 1, 2, 3, 4, 5, 6, and 7 steps that you must follow. It's recommended that you follow all these 7 steps so that you can actually solve for the mass balance problem. So step number 1 is basic. Okay, you must read the question and you must understand what the question is asking you to find. Okay, so that is the meaning by read and understand the problem statement. So it's not that complicated. So for today we're going to be looking at step number 2, step number 3, and step number 4. And for me, these 3 steps, step number 2, number 3, and number 4. So this one, and this one are some of the important steps. So if you make something wrong in these 3 steps, you will have difficulty to solve and get your final answer. Okay, so again, step 7 is just to recheck whether you have done correctly, whether you have answered whatever the problem is asking you to find. Okay, so step number 5 and 6 we'll be looking at in our next week class, where we'll solve a few examples where we can actually apply step number 6 and step number 5 and step number 6. So today we're going to be looking at step number 2 first. So choosing a basis. Okay, basis is something that you choose when you want to start your calculation. Okay, that's it. So it's just a number. It can be 100, 1000, 10,000, 1, whatever it is. And it can be 1 kilo, 100 kilo, 1000 kilo, 100 mole, so on and so forth. So there are 3 questions here you must ask when you are choosing a basis. Okay, the first thing is that what do I have? Second is what do I want to find? And third thing is that what is convenient? So if you answer these 3 questions by right, you should be able to find your basis. Most of the time, this is your situation. Okay, situation 1 and situation number 2. If the amount of flow rate is given, use that as your basis. Don't use some other numbers. Okay, and in an example, we look at what I mean by this. Second is that if several amounts of flow rates are given, use them collectively, meaning that you can have one value as your basis and you can have more than one value as basis. If there are 2 values given to you, then you can just use those 2 values as your basis. Okay, if you have 3 values, then use all 3 as your basis. Okay, and then if no amount of flow rate is given, assume a convenient amount of flow rate. Okay, if the question just gave you if the question did not give you any value to start with, you can assume your own value. And usually I would suggest that you assume a value of either 100 or 1000, depending on your question. It can be 100 kilo, 100 gram, 100 mole, 100 pound, 100 meter cube, whatever it is, because you can start with a number of 100 or 1000. So it's a simple value. Okay, convenient value. So if you have appropriate basis, simple basis, then your calculation will be easy. If for example you want to choose the basis of 80, right? The question did not give you any value and you say you want to choose a value of 80 kg as your starting value. Is this wrong? No, it's not wrong. You can choose whatever value you want. But if you choose an odd number, your calculation will become much more difficult than it was supposed to be. So you are adding extra pressure to yourself for no reason. That's why we always go with 100, 1000 or 10 or 1, depending on the situation. If you say you want to go for 99.99, go ahead, no problem. Okay, but this is not recommended because it will cause your calculation will be difficult. Okay, so this is the first example. So this example will actually use for our step 2, 3 and 4. Okay, so for this first step, as we said that, first of all, we read the question. Read the question and understand the problem statement. So the question is saying that a continuous mixer mixes NaOH with water to produce an aqueous solution of NaOH. So here, first of all, you have to understand what does it mean by aqueous solution of NaOH. Okay, when you say aqueous solution, it is always a combination of NaOH and water. Okay, so the question, so this is the question. Okay, determine the composition and the flow rate of the product. Okay, determine the composition. So you have one thing, this is the first thing that you need to find, the composition and the flow rate of the product. Okay, flow rate of the product. So this is the second thing that you need to find. If the flow rate of NaOH is 1000 kg per hour. Okay, so step 1, read and understand the problem statement. So you need to find first of all the composition, right? And 2 is the flow rate. So flow rate here will be your mass flow rate, right? Because, okay, so, and the ratio of flow rate of H2O to the product solution is 0.9. Okay, so this is additional information. So by looking at this question, okay, if you go back to our, this one, if, so this is our first condition. If the amount of flow rate is given, use that, right? It says that. So in this question, I know that I am given a value here, 1000 kg per hour. So automatically, if I know I have a value given, then I can just say that my basis is 1000 kg per hour. That's it. That is my basis. Okay? Clear? Everybody understand? So that is how you choose basis. Any issue? Anybody have any problem so far following the lecture? Okay? Good. So that is the first example. So let us go to the next example. So example 2. 2 methanol water mixture are contained in a separate flask. The first mixture contains 40% methanol. So if it's saying 40% methanol, the rest will be water. So I can know here that 60% is water, H2O. Okay, and the second container contains 70% methanol. So I know that I can say that 30% is H2O again, because it is a mixture, right? It's saying here it is a mixture. If 200 gram of the first mixture is combined with 150 gram of the second, what are the mass and composition of the product? So again, our problem statement is saying that we want to find what is the mass. That is the first thing that you want to find, and also you want to find the composition. Okay, so this is our first step. We already read the question and we understood, and from our understanding with that, we know that we have to find the mass of product and the composition of the product. So here we have two values. Okay, from flask number 1, I say F1, I have 200 gram, right? From F2, flask number 2, I have 150 gram. So our second condition is that if you have more than one value given, use them collectively. So now, since I have two values, F1 and F2, from flask 1 and flask 2, so both are these are my basis. Okay, so that is all on how to choose basis. Okay, so now we move on to our second part, which is draw and label a flowchart, or sometimes we also call this process flow diagram, because it is a diagram that shows the flow of our process. Okay, when you are drawing and labeling the flowchart or process flow diagram, you have to follow all these things. Okay, enter all known variables including basis. Okay, so that is why basis was our first step. Once you read the question, you understand the question, you decide the basis, then only you start drawing your flowchart. Okay, label unknown variables, include each component and incorporate relationships. So for example here, if in the question it gives us that if the flow rate of stream 2 is twice the flow of stream 1, you can write F1 and to F1 instead of F1 and F2. Okay, so this is just an example. So basically it's saying that whatever information you have in your question in the text, you have to convert it into a flowchart. So why is this important? Because this is important for our step number 4, performing degree of freedom analysis. So again, this is our previous example. The same example, we have to determine the composition and the flow rate. So just now we already assume, right, again, basis is 1000 kg per hour, right? So I know now I've done my basis. Second step, third step is to draw. So now I know that this is a continuous mixer, right? So usually we just draw a square, okay? And I can put here mixer, M or mixer, you can write it. So I know that NaOH is mixes with H2O. So I know that my first stream here going in must be NaOH. Okay. The second stream is that I'm mixing NaOH with water, so I can put here H2O. Okay. And then whatever is coming out is a mixture of an aqueous solution of NaOH, meaning that I have NaOH and also H2O. Okay, those are the things that I know. And I also know that the basis that we've chosen for NaOH is 1000 kilograms. So I can write here F1, okay, or M1, doesn't matter, it's same thing. Okay, F, M or anything is just a symbol. It's going to be 1000 kg per hour. Okay, so I know here that here the only thing I have here is NaOH. There's no other component here. So I can write here my weight fraction, okay, W NaOH is equal to 1. Okay, because I know that whatever stream, whatever material I have in this side of the stream, it's just NaOH. So my weight fraction is 1 for NaOH. So now I go to my second stream. Now if I read the question, I see that I have no information whatsoever about H2O. The only thing is that it mixes with NaOH. So I don't know the value of the feed of the flow rate. So I can write F2 or M2, doesn't matter. I don't know the value, but I know that this is 100% water. There is no NaOH here. So I can write here again the weight fraction of H2O is equal to 1. Okay. And then I go to my third stream here. So water and NaOH is mixing and is producing an aqueous solution, meaning that it has some NaOH and some water. So that's why we want to find the composition, right? Determine the composition and flow rate. So in terms of the flow rate, since this is my product, I can write it P or I can write it as M3. I don't know what is my product value. I don't know what is my M3 value, which is my product flow rate. And I also don't know. So from here, I know that since I have two components here, So I can see here I have weight fraction for NaOH, and I also have a weight fraction for H2O. Okay, so these are all the things I can label here. So until here, and then it says that the ratio of flow rate of H2O to the product solution is 0.9. So I know that I can also write at the bottom here the ratio between flow rate of H2O. So I can say that F2 over my P is equal to 0.9. So this is the meaning that any relationship you have here. So based on this, I can say that my F2, okay, based on this relationship, I can say that F2 is equal to 0.9 P. So what I can do here is that instead of writing F2 here and M2, I can just write here 0.9 P. Okay, so this is how you label your process flowchart. Completely, you have put all the variables, I have put all my bases, I have put all my relationship in the flowchart. Okay, so this is our third step. Draw and label a complete flowchart. Okay, anybody have any question?